Hi guys, let's look at the last exercise of this chapter, exercise 15E. You would have noticed I have not done exercise 15D. That's because 15D has been cancelled from this year due to lockdown. So let's go ahead and do 15E, which is basically a revision exercise. So in this question, it's given that there is a trapezium ABCD and certain pieces of information are given. Let's just write that down. This is 9 centimeter, BC is 18 centimeter, CF is 13.5, AP is 6, BE is 15. We need to calculate EC, AF. EC is here, AF the long line, and we need to calculate BE. So let's try and prove two triangles similar, which means in triangle ABE and triangle ECF. These are the two vertically opposite triangles. Let's see what we get. We get angle BEA is equal to angle CEF. These are vertically opposite angles. And the next thing we get is angle BAE would be equal to angle CFE. These are alternate angles because AB and CD are parallel, which means therefore triangle BEA is similar to triangle CEF by AA test. Let's try and get the ratio of their sides, which means what I'll get is BE upon CE would be equal to BA upon CF, which would be equal to EA upon EF, and this is CSST, which is corresponding sides of similar triangles are in proportion. Let's see if I have any values. BE is 15, CE what I need to calculate, BA is 9, CF is 13.5 is equal to EA not given and EF not given. So I can calculate CE very easily from this. So it will be CE is equal to 15 into 13.5 upon 9. So this is 3 into 3, this is 3 into 5, this is 3 1, 3 4s are 12, 4.5. So this is 5 into 4.5, that's 20 and 2.5. So this is 22.5 centimeter. So therefore CE is equal to 22.5 centimeter. First part of my question is done. Let's see what's the second part and what we'll need to do for that. So let's look at the second part. So I've got CE is equal to 22.5. Next, we need to figure out the value. So CE done, we need to figure out AF. So where is AF? AF is the big triangle here, which will form a part of triangle ADF. Can we get anything from there? Yes, maybe if I can try and prove ABP and DPF similar. So let's look at these two triangles. So in triangle ABP and triangle FPD, what do we have in common? This is point number 7. This will be point number 8, which says again vertically opposite angles here. Angle P and P and angle A and angle F will be equal because these are alternate angles. So I should be able to prove them similar. Angle APB would be equal to angle FPD. Reason is vertically opposite angles. And then the second one would be angle PAB would be equal to angle PFD. These are alternate angles. So what this gives me is triangle ABP would be similar to triangle FDP. This is by AA test. Yes, A would be corresponding to F, P corresponds to P, D corresponds to D. Let's just write the CSST for this. This would be AB upon FD would be equal to AP upon FP is equal to BP upon DP. This is CSST. Let's see if I have any values available. AB is 9, FD is 18 plus 13.5. So I have some figure here. AP is 6 and FP we don't know. BP, how well we don't need to know. bother about BP and DP because we are not supposed to calculate them. So let's look at this. This would be FP would be equal to 6 into 18 plus 13, that's 31.5 upon 9. 5 plus 3, 8 plus 9, divisible by 9 for sure. So 9 into 3, 27. That's 45. So 9 5s are 45. So 6 into 3.5, which means this would be 18 and 3, 21 centimeter. So FP is equal to 21 centimeter, but we need to calculate AF. So we've got FP as 21, we've got AP as 6, which means AF will be equal to 21 plus 6. So therefore AF is equal to AP plus PF is equal to 27 centimeter. So we've calculated AF as well. So second part of the question done. Let's look at the third part. Now we need to calculate PE. So is there any place where we have PE? PE, I can try and prove APD and BEP similar. I will not be able to because only this angle is equal. These lines are not parallel. Let's see if I can get anything else. I notice I have EA upon EF here. Yes, EA upon EF here. Let's see if it will give me something nice. Right. So from 5, I have point number 16. EA upon EF is equal to 9 upon 13.5. This is nothing but 4.5 into 2 and 4.5 into 3. So this is 2 upon 3. And what is EA? EA is nothing but the big one, AF minus FE. So this is AF minus FE upon FE is equal to 2 upon 3, which means AF upon FE minus FE upon FE is equal to 2 upon 3, which means this is 1, which means AF upon FE is equal to 1 plus 2 by 3, which is equal to 5 upon 3. Do I have the value of AF? Yes, the value of AF is 27. Do I have the value of FE? No, I do not have the value of FE, and this is equal to 5 upon 3, which means FE would be equal to 27 into 3 upon 5. This is 5.1, 5.5, 5.4. So this is 15 and 1.2, which means this is 16.2 centimeter. So I've got the value of FE as 16.2. I've got the value of FP as 21, which means I should be able to figure out the value of PE. I will erase the first part of my question because I'm left with no space here. So I will just erase this part and I will continue in a different color so that you notice that this is not the first part of the question. This is coming right at the end. So PE is equal to FP minus FE, which means PE would be equal to FP, which is 21 centimeter, minus FE, which is 16.2 centimeter, which is 4.8 centimeter. Therefore, PE is equal to 4.8 centimeter. Very interesting question, long one as well. Took us some time and it had different parts, so very nice. Let's look at the next question. The next question that we solve is question number 4. Let's look at question number 4. It says triangle ABC is similar to triangle PQR. Okay, so let's just draw two rough diagrams. Okay, so triangle ABC is similar to triangle PQR. AD and PM are corresponding medians. Let's just draw the median, and a reminder, median divides the base into two equal parts. Okay, which means this is D and this is PM. So BD and CD are equal and QM and MR are equal. What we need to prove is AB upon PQ is equal to AD upon PM, which means that they are in the same ratio. Good. Let's just look at this. So since triangle ABC is similar to triangle PQR, what basically we need to prove is triangle ABD and PQM are similar. Let's see how we can prove it. So since these two triangles are similar, which means angle ABC, which is nothing but angle ABD, is equal to angle PQR, which is the same as angle PQM. This is corresponding angles of similar triangles are equal. So what I'm saying is this angle and this angle are equal. What I also have is AB upon PQ is equal to AC upon PR, which is equal to BC upon QR, which is CSST. Corresponding sides of similar triangles are in proportion. Good. So we've got these two. Let's see if we can get something right. So what we also have is BD is equal to CD is equal to half of BC, and we have QM is equal to MR is equal to half of QR. Reason, since AD and PM are medians, which means they are dividing the base into two equal parts. So which means 3 would also give me BC is equal to 2 times BD, and QR is equal to 2 times QM. Correct? So put 3 and 4 in our equation 2. Let's put 3 and 4 in 2, which means what we get is AB upon PQ is equal to, instead of BC, I'm writing 2 times BD, and instead of QR, I'm writing 2 times QM. So 2 and 2 gets cancelled, which means AB upon PQ is equal to BD upon QM. I can also write this as AB upon BD is equal to PQ upon QM. Why did I do this? Because I am now looking at a side angle side way of proving it. What we get is AB upon BD. This is what the left hand side here is, and is equal to PQ upon QM. So the corresponding sides are in ratio and the included angle is equal. So I've got my answer already. I just need to write that down. So since corresponding sides are in same proportion and included angle is equal, therefore by SAS test, triangle ABD is similar to triangle PQM, which means what I get is AB upon PQ is equal to AD upon PM is equal to BD upon QM. This is CSST, and that's what they wanted us to prove. AB upon PQ is equal to AD upon PM. Very simple, but required us to use the property of the test of similarity of SAS. Good, let's look at the next question. The next question that we do is question number 8. Let's look at question number 8. It says, in the following diagram, L, M, N are parallel to each other. Prove AB upon BC is equal to PQ upon QR. So if I go ahead and remember the trick that we talked about, AB upon BC. So if I take BC here, this would become PQ upon, and here would be QR. So I need to look at triangle ABC. Doesn't work because ABC in a straight line. So let's try and create a triangle first. I don't even see a triangle here. So let me join AR and see if this will help me. I could have also joined CP. I have decided to join AR. So number 1, join AR, let it meet BQ at point D. Yeah, let's name this point D. So now let's look at what do we get. since BD is parallel to CR using basic proportionality theorem, what I get is AB upon BC would be equal to AD upon DR. Done. We've done this in the first set of parallel lines. Let's apply the same logic in the second set of parallel lines in the reverse triangle. So this was for in triangle ACR. Let's look at the reverse triangle, which is in triangle APR. Since DQ is parallel to AP, using basic proportionality theorem, what I get is AD upon DR would be equal to PQ upon QR. So from 3 and 5, what I get is AD upon DR is equal to AB upon BC, which is equal to PQ upon QR, and that's what they wanted me to prove. So hence proved. Done. Simple question. All it required was for us to identify the triangle, and then once we created the triangle, there was nothing else in this question. Good. Let's look at the next question. The next question that we do is question number 9. Let's look at question. It says in the following figure, these are DE and CA are parallel and CD and AP are parallel. We need to prove BE upon EC. So BE upon EC is equal to BC upon CP. Again, I don't see a straight, this is a straight line even if I take BE or BC, or I take, so I can't figure out which triangles to prove similar. So let's try and use some logic and see how we can move on. So let's look at this triangle first, which is triangle BAC, where I have DE parallel to the base. So let's just write that down. In triangle BAC, since DE is parallel to AC using basic proportionality theorem. Now this looks like exactly this question that we just did. It's exactly the same. Right? So what we get is BE upon EC is equal to BD upon DA. BE upon EC is equal to BD upon DA. Perfect. Now let's look at the second triangle and let's see if I can get something from there. So which triangle should I look at in the second time? Let's look at the big full triangle BAP, where DC now is parallel to AP. So in triangle BAP, since DC is parallel to AP, using basic proportionality theorem, what I get is BD upon DA would be equal to BC upon CP. Let's combine 2 and 3. So from 2 and 3, what I get is BD upon DA is equal to BE upon EC, which is equal to BC upon CP. That's what they wanted us to prove. So done. Exactly similar to what we just finished. Okay, that finishes this video for me. Before I leave, let me just mark some homework questions for you. Homework question for you would be question number 5 and question number 6. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye bye.